So in the previous video, we have seen about transpiration. In this video, we are going to combine both evaporation and transpiration losses and give it one single name, that is called as evapotranspiration. So give the heading evapotranspiration. So as the name suggests, it is the sum of both evaporation and transpiration losses. So sum of evaporation and sum of evaporation and transpiration is evapotranspiration. Okay, so sometimes this evapotranspiration, in terms of instead of evapotranspiration, there is a term which is called as consumptive use which is used. So these both terms are same. So consumptive use, it is same as evapotranspiration. Evapotranspiration. Okay, so in the previous videos we have seen some definitions like iso heights, iso nips, correct? So this was the point or line which is joining point of same rainfall. So isonip was point joining a line which is joining the points of equal snowfall. So in this we have one more isoterm, that is called as isoplates. So isoplates. So this is line joining equal evapotranspiration points. Okay. So these three isos we have discussed up to now: iso height, iso nip, and isoplates. Okay. So these are the 2 points which we have discussed. Now let's go to the types of evapotranspiration. The next point: types of evapotranspiration. Types of evapotranspiration. So there are two types. First one is called as PET and the second one is called as AET. So the PET stands for potential evapotranspiration. So potential evapotranspiration. AET stands for actual evapotranspiration. Now what is the potential evapotranspiration? So it is the evapotranspiration which would occur. Okay, so it is the evapotranspiration, that is sum of evaporation and transpiration, which will occur when the soil is containing adequate water to meet the needs of plant. So it is evapotranspiration which would occur when soil contain adequate water to meet the needs of plant. Okay, now what is actual evapotranspiration? It is the actual evapotranspiration which is occurring at that given place and given time. So it is the evapotranspiration which occurs at given place and given time. So one is under ideal conditions and one is actually what is happening. Okay, so these are the two types of evapotranspiration. So going to the next concept now, there is some relationship between AET and PET that we have to discuss. So relationship between PET, AET and MC. This MC stands for moisture content in soil. Okay, so let's draw here two limits. This is the upper limit and this is the lower limit. So upper limit and lower limit. Now this upper limit, it is, we are giving the name of this upper limit as field capacity FC. Field capacity FC. Okay, and this lower limit, it is called as permanent wilting point. Permanent wilting point, PWP. Okay, so this is the upper limit and this is the lower limit. Now whatever the amount of water, first we will write down what is this field capacity and permanent wilting point. So the first definition is about field capacity FC. Okay, so field capacity is the maximum quantity of water. It is the maximum quantity of water that the soil can retain. That the soil can retain against gravity. Okay, so maximum how much water the soil can retain, it is called as field capacity FC. Second definition is PWP, permanent wilting point. So permanent wilting point is also the quantity of water only. What is the difference in that? The difference is that if the water level goes below the PWP, that is the permanent wilting point, then there is the wilting of plant, that is the plant dies. So permanent wilting point is moisture content of soil at which plant wilts. Okay, so this is the permanent wilting point. So this is the minimum water that should be present, otherwise the plant will start wilting. So if we take the difference of this, that is field capacity minus permanent wilting point, so what we will get? We will get the available water, or we can say available moisture content. So this is available moisture content, also called as AMC. So whatever the available moisture content is there, that will be present between these two levels, between the upper limit and the lower limit. Okay, I hope you are getting it now. So let's start discussing one by one all the cases. So first case is when moisture content is equal to field capacity. When the moisture content is equal to field capacity, the ratio of AET, actual evapotranspiration, by potential evapotranspiration, this is equal to 1. Okay, now second case, when moisture content is less than FC, it is less than field capacity. So you just look at this diagram. If this field moisture content, if it is present at this point, field capacity, then available moisture content and field capacity, this both will be same. So AET by PET will be equal to 1. If it is less, then AET by PET, this will be less than 1. And if the moisture content is at permanent wilting point, that is if moisture content is equal to permanent wilting point, then in this case the AET will be equal to 0. If the AET will be equal to 0, then AET by PET will be equal to, this will also equal to 0. So from this we can define the range for AET by PET. So the range is 0 to 1. So it cannot be less than 0 and it cannot be greater than 1. It can be anywhere between the 0 and 1. So these are the relationship between AET, PET and the moisture content. So now we are going to see what are the various methods of measurement of evapotranspiration, and then from the next video we will discuss them one by one. So give the heading methods to measure evapotranspiration. So total we have three methods. The first is called as lysimeter. Then second one is Penman's equation. And third one is Blaney-Criddle formula. Okay, among these two are empirical equations. Okay, so these are the methods. Now from the next video we will start the one by one each method.